Welcome back. In the previous video, we saw that what are quality requirements. In this video, I will discuss requirement quality assurance. What is requirements quality assurance? Requirement quality assurance checks whether the requirements meet the desired quality attributes, that is like the correctness, completeness, and some other attributes that we discussed in previous video. Quality assurance of the requirements is important because the cost of imprecise requirements is sufficiently high. Also, quality assurance in requirements engineering has a high impact on the quality of the product. Now, the next question is that how exactly do you test your requirements? So for that, the best way is to introduce a requirements analysis stage that has to be done before the coding or the design of the system starts. So since no one knows a product as well as a tester who works with it every day, so it's always a good idea to have a quality assurance check for all the requirements, specifications, and mockups that are done at this stage. So the goal of quality assurance in requirement engineering is to check that the items specified in a requirements document meet the desired quality attributes, for example, the completeness, correctness, adequacy, or any other attributes. So why is requirements quality assurance important? So here we have some an important fact presented by Bohem and Basili. And according to this, finding and fixing a software problem after delivery is often 100 times more expensive than finding and fixing it during the requirements and design phase. This shows that the cost of not properly performing the requirements and design activities is very high. Therefore, a particular attention at the earlier stages of the system development, for example, requirements design, helps in avoiding the defects and the unforeseen costs at the later stages. Here we will see some common defects in requirements. For example, noise, overspecification, unfeasibility, unintelligibility, and poor structuring, etc. So here we have listed some requirements related to different software systems, and we discuss the defects or problems with those requirements. The first one is noise. In this requirement, in fact, lots of information is presented that is actually difficult to comprehend or to be implemented in a single requirement. So a benefit of such noise in the requirements is that sometimes some of the important requirements in a particular statement or parts of the requirement, they might not be implemented. So here we see that the requirement statement is that every train car will be equipped with a software controlled information panel together with non-smoking signs posted on every window. So the requirement is containing lots of information which is in fact difficult to comprehend and memorize. Then over specification. This requirement is overly specified. For example, the set alarm method must be invoked upon receipt of stop alarm message. So like set alarm method, stop alarm, these are some technical words, and since we also encourage the users to be involved while we are analyzing the requirements, so these technical terms that are actually resulting in over specification of this requirement, they might be irrelevant to the users or customers of the system. Similarly, Sometimes the requirements stated are unfeasible, means they are not it is not possible to implement those requirements under the given constraints or available resources. For example, here the statement that the meeting scheduler will also make travel arrangements such as flight, car, and hotel reservations for every participant who needs to travel to attend the meeting. So this requirement is highly unfeasible because we cannot expect such functionality of reservations, flight reservations, car reservations, and hotel reservations from a single meeting scheduler. So this requirement is again having some problem. Then unintelligibility, that a requirement might be containing lots of information that is difficult to relate. For example, it contains lots of acronyms in a single statement. So those acronyms without definition, they might be difficult to remember for the development teams. Similarly, the requirements might be poorly structured. For example, they might be the requirement might be uh, interlinking two entirely different concepts in a single requirement. For example, here we have a requirement intertwining of book acquisition and loan management aspects. So apparently they both are the functions of some library information system, but book acquisition and loan management, they actually are two different related to two different modules. Book acquisition means that acquiring the library books from some vendors or providers, whereas loan management deals with dealing with the patrons or the users of the library system. Therefore, it is important to validate the requirements during the requirement stage to avoid these problems, because they might lead to defects in the subsequent development stages of the system. So, cost of requirement defects are errors. So here we see a comparison in terms of total effort spent on fixing the errors in the software system when we perform the requirements validation as compared to the situations when this activity, that is requirement validation, is not performed. It can be seen in the left figure, that is when requirement validation is not performed during the requirement engineering process. So the effort spent on fixing the errors goes very high. Particularly, it reaches its peak at the later stages, as you can see. For example, implementation errors and testing stage, it has high ratio of errors, whereas the figure at the right shows the scenario when the validation of requirements is performed. In this case, the effort spent on requirements in the start is although a little high, but you see here in the later stages, for example, the implementation and testing stages, the effort on fixing or correcting the errors are not that high as in the other case. So this is an indication of the importance of the quality assurance activities during the requirement engineering process. So here we are heading towards concluding our discussion on performing the quality assurance activities at the early stages of the requirement. In fact, requirements related problems, they linger in the product until the products are until they are finally revealed through the time consuming system testing activities, or they are reported by the end users while the system is being tested by the users. So if we start our test planning and test case development in parallel with requirements development, we will detect many errors shortly after they are introduced. This also prevents them from doing further damages and minimizes the development and maintenance costs as well. So this concludes our discussion on uh, uh, quality assurance activities in requirement engineering. In the next video of this lecture, I will discuss the requirement verification and validation techniques. Please watch that video. Thank you. The materials in this video are based on these three sources. For further details, you can consult these sources. Thank you.